Guys, Data Pandas here. If you don't know me yet, I'm a software engineer and data scientist, and Data Pandas is an ongoing project that will help you to create your own coding knowledge. Today we are gonna see a full tutorial on Pandas Python, but before starting, if you enjoy the video, please don't forget to subscribe to my channel, and that's small things but will help me a lot to bring more quality on my future videos. So today we're gonna see, like I said, a full tutorial in Pandas. This is our index, and in this index we can start with a brief introduction about what is Data Pandas, what is the main use case, how to install Pandas, how to read a file, a CSV, Excel, SQL, JSON, Google Sheet, what is the difference between lock and ILOC, and how to navigate inside the data frame, what is slicing, either column, index, series, data frame, what they are, how can I use that, and then how to modify a table with all the subcategories, and a brief conclusion to wrap up our full immersion course. So a brief introduction, what is Data Pandas? Probably if you click on YouTube Pandas Python, you already know what it is. But basically, like the definition, if you search on Wikipedia or online, Pandas is a software library written in Python for data manipulation and analysis. It offers data structures and operation for manipulating numerical tables. So this is an error here, just like this, numerical tables and time series. And the main use case is every time in your job, in your university, in your life, if you will need to work with tables, Pandas can be your best friend because it's built to work with tables structure very similar to a table, to a two-dimensional database, to a two-dimensional tables. So for example, if you have to modify table adding a new column, merge values between two different tables, creating graphs, creating amazing plots, Pandas will be your friend. So the main use case are around the data analysis, the data manipulation, data visualization. This is the main core that use Pandas. First of all, how to install Pandas. Usually I use Anaconda. You can find a lot of stuff around Pandas, around Python in general. For example, you can have you can create an environment where you can work with different type of project. Python environment. You can use you can launch Jupyter Notebook from here, VS Code, Spider, PyCharm, and a lot of stuff around Pandas, around Python and Pandas as well. But to start a Jupyter Notebook is very easy. You can just open Anaconda and start a new Jupyter Notebook. Is very, very easy to do. And here you can find a lot of stuff around this is the directory where you run the command. So say for example, if I want to go inside my just to kill Control C, if I want to go inside my project, let's say for example that's my directory I want to open. Very quickly here we can open, for example, we can create a Jupyter Notebook from here and work inside the Jupyter. Right now I already did, so we can just following this Jupyter Notebook already created. First of all, we need to install Pandas. We can install Pandas right here inside the notebook with this command. Very handy command, very easy to use. So that's about how to install Pandas. How to install Pandas. If you want just a quick tip about Jupyter Notebook. If you want to, if you like to modify the type of the cell, you can just double click M, and here you can find a markdown cell instead of coding cell. If you go inside the cell, for example, you can see that you have different cell type: code, markdown, and row MB converter. Just skip for a moment this type. We have two types, that is code and markdown. So this is one is a markdown. You can use, for example, to do the table of contents. It's very handy to create an index with a table of contents. And you can use also to adding some comment like this, how to install Pandas. So if we run this command, we have Pandas installed. But let's jump into what is the great powerful of Pandas. First of all, I already installed, of course. I can import a very easy way, just doing like this. Import Pandas as PD, and then I need to have a dataset. To work with Pandas, we need a table, we need a dataset. So for the dataset, I suggest to you a very nice dataset that is about Harry Potter, and you can find in Kaggle. Kaggle is a very famous framework, a very famous website where you can find a lot of stuff about data science, dataset world. So here we can navigate just into this dataset. In here you can find, for example, the character ID, the character name, the species, the gender, house. For example, the first one is Harry Potter. Is a human, is male, is Gryffindor, etc., etc., etc. And you can find here a lot of tables that is very, very handy to make practice in data analysis in general. There we go. I already downloaded all that stuff, and you can see that I have a lot of tables, CSV, that I can use to work with Pandas. So say, for example, right now I have a problem, and my problem is where I am, in which directory I am. If I import OS, it is very handy things to work with environment, to understand the directory, the position, operation system, activities in general. You can find that we are inside this path. I want to move to another path, and the path is this one. So I can just copy this path and just save here, because I want to change the directory where I'm working with the directory of where is in particular this dataset. So let me just copy this type of code you can use. Of course, I will share with you this Jupyter, and you can use every time you need. Sorry, just made a mistake here. So let me just copy this one, put in here, copy the code from another part, perfect, and just put in here. So very simple. I specify the path like a string. The problem with Windows is the backslash is not recognized, so I replace the backslash with the I don't know to say the normal slash. Now we say with the right slash, and change the directory. So right now I'm in the good directory, and I can read the file. How can I read the file? Very easy way. I can just read the file like here. To read a file, we have a CSV file. See, we have a lot of CSV file. We want to read, for example, the characters one. How can I do that? Very easy. df usually stay for data frame. So just a comment, df is a data frame. Dataframe is a structure, internal structure of Pandas that is very similar to a table. I show you very quickly, and to read the file, just go pd read csv, and then we can just copy the name of the file that we want to read. So let's say, for example, this one. I'm just putting here. I have an error. Let's see why. No such file or directory. Let me check where I am, in which directory I am. Oh, I am in the same directory that before. So I run this one, and now perfect. I'm in the same directory where the data is stored. So I can run very quickly this one, and now I can see the dataset here. The dataset now is stored inside the data frame. So we can navigate this dataset very quickly. Say, for example, df.head, and then replace with 10. With this command, I can read the first 10 row. And another things could be read the last 10 row. With this one, we can just read the last 10 row of the dataset. A very handy thing is to do Alt Enter to create a new row. Is a shortcut for Jupyter. Alt Enter. We can create another row. So that's so right now we can see our dataset. We can see a lot of stuff of our dataset, and Pandas is very powerful. Let's jump, for example, into a question. If I were to ask to you, which is the most common, for example, gender in Harry Potter movies? So we have a column gender. Here we have a lot of null. But here we have, for example, May, Harry Potter, Ron Weasley, male, Hermione Granger, female, and so on and so forth. To do that, don't worry right now. I just want to show you the powerful of Pandas, and then we can specify what is a group by and how can I use a group by. But here the concept behind is I'm doing a group by for the gender, and I'm just counting how many gender are there. So let's see, group by, perfect. I have 42 female, 1 human, probably is someone that is not recognized inside female or male, and male, 82. We can just do with this one, we can just do, for example, a graph. We can just do a plot, just like this. Very simple prompt. We can specify the type of the plot. We can specify, for example, we can just do say, for example, bar. Here now you can see I can overlap the plot. Or what I can do is, for example, let me just commenting very quickly, just putting this one here and removing this one. I can just put kind equal pay, and we can have a cake plot. So what else we can do? We can do a lot of stuff. Right now, a problem could be, so that's why an overview, a very easy, very fast overview about what we can do with Pandas. But right now, let's jump into moving around the dataset. A very powerful things is using lock. And lock is, and just link with you. lock, you can find a very good documentation about lock on the official dataset official page of Pandas. For example, you can find here. And lock is a way to access a group of rows and column by labels or Boolean array. Let's just written this definition here and just copy this link for you if you want to use in the future. So I show you just an example, and then we can work together to better understand how lock is work. So we can do just def dataframe dot lock square brackets 0, comma, and then we can just put, I don't know, gender. See, very easy. What's happening here? Here, right now, we are trying to access, to read inside the data frame, the element, the item at 0 position and the gender column. So just let me explain better how lock is working. So we have a data frame that lock, and then this function taking input two values, input 1 and input 2. Here is taking input frame that lock. What is the input 1? Input 1 is the row, basically, and input 2 is the column, basically. The data frame that lock. What is the row? The row is the row or the rows you want to get, and the column is the column or the columns you want to get. Let me just put in a space between that just to be more clear. That's the way. So just here, what I take the 0 element. So if I plot again the dataset, you can see very easy way, the 0 element and the gender of the 0 element, male. If I want to plot, for example, the name, just very easy, I can double click, and so Harry Potter is the 0 element. And this is very useful if you want to, for example, loop the dataset. If you want to take some specific element, you can do in a very easy way. Let's say, for example, if I want to take more than one row. To take more than one row, I can just do, to take all the dataset in a very easy way, I just do it. It's the same. It's the same. Like here, I take all the dataset, and it's mean all the rows and all the columns. If I want to take, for example, the first 10 elements, in a very easy way, I can do from 0 to 9, that is the first 10 element, comma, and then all the columns. And here I can see the first 10 elements. I can take, for example, from the 10 to 20. And here I can say the 11, because here are 11 new characters. If I want to take more than one row, we already see. If you want to take more than one columns, what I have to do is open here a square brackets and just putting the name. It's very important. The name is the label, just like this. I have to put the name of the columns. Perfect, just like this. And here I can access to the 2 exact column. So let's, for example, and this is very important because it's label based. It's very handy if you want to navigate to database. It's not so handy, it's not so useful if you want, for example, iterate the database. To iterate a database, probably is better another function that is called ILOC. ILOC, let's see here, for example, if I put just here ILOC, I can see a good documentation about ILOC. Like say the name is a purely integer location based indexing for selection by position. So that's ILOC. I left the link for you as well. No, I copied the wrong part. So how is work ILOC? Is like lock is a way to access to my dataset, but using index, using integer. So if I want to access, for example, let's say, for example, what's happened if I copy this one and I put just EI near lock? I got an error, of course, because location-based indexing can only have integer. So it's purely integer location. To do the same, I can just put here 1. If I put 1, I can see Harry Potter, because Harry Potter is the 0 row and 1 column, because 0 column, 1 column, 2 column, 3 column. And it's very handy if we don't know, for example, the name of the column, or we don't know yet. It's very handy to see, for example, the first 9 column of this 0 element. Or I can just plot the first 20 rows, and I can see from 1 column to 10. For example, I want to skip. Okay, we start very quickly with the slicing, the concept of slicing. Like I say, to transform a cell from coding cell to markdown cell, double click on them here and see it's changed the coding type. And now we are just adding the slicing. Slicing, like we know, is about cutting, is about cut my data frame. Let me just googling it. Slicing data frame pandas. So it's just cutting. It's about cutting our data frame. Say for example like this. And we just copy the images and put in here. We are doing a slicing. So how can we work with slicing? If I want, for example, give a response to this question, how many characters has as first letter the H letter? So, for example, Harry Potter, Hermione Granger has the H letter as the first letter of their full name. So, to do that, I can use, for example, lock. Let me use lock, but it's indifferent using lock or using ILOC. Depends if you need to think with the indexing or if you need to think with the label. Right now, for me, it's easy to think with the label. So I just copy the name of the columns that I need. For example, this one. If you want to respond to the questions, how many characters have as first letter the H letter, we can just use lock. You can use ILOC as well. It depends on you. It's up to you. So here we have Harry Potter, Ron Weasley, etc. I want to do just a filter of that. To do a filter, like we see in this page, in the lock function, we can see very clearly that we can use inside lock not only a column based, a label based, sorry, but it also a Boolean array. How we can use this Boolean array? Say for example, I want to understand, I want to find a response for these questions. So what I have to do is to do just, I want to understand if I take all the row and I take all this column, so just copy this one, if it contains the letter H and start, so start with the letter H and then I have a lot of characters. I can use a regex just like this and became true. I got an error because this is a series and is not as not contains. A series as not contains. We can just clarify this aspect very quickly later. Here I can have, okay, that's good. I got an array of true or false. So if an element has the letter H, like the first letter of its name, I got true, otherwise I got false. This is a condition that I need. So this is my condition array on rows. Just let me copy this one. I can slice the data frame with this condition. How can I do that? Very simple way. Data frame dot lock, open the square brackets, and then my condition. Just copy my condition name, and then I want all columns. Maybe I have an error, I don't copy properly this name. Let me just copy it again. Perfect. Now I got the only element which has a name, for example, Hagrid, start, the surname start with H, Hermione, the name start with H, Harry Potter, I don't know, Honch, etc., etc. So that's a way to do a slicing, so to cut a portion, a part of my dataset with a condition. I can concatenate the condition as well. Say for example, if I want to take this condition and combine it with another condition, just let me do one hand. For example, I want only the male characters, so that is male, and gender is male, contains male, it's fine. I copy the second condition again, just copying. Okay, I got the only third characters that has H as the first letter and male as gender. Very easy way to cut, to slice my dataset. So we can read an Excel as well. So we just see how to cut, how to navigate inside the dataset, how to read a dataset in CSV, and now we can just jump into read an Excel file. How can I read an Excel file? Read an Excel file. Let me, for example, creating this Excel file. We can just open this one. We can just file, create a new book. Perfect. And we can just, let me very quickly open it. We can just use df equals pd dot read Excel, open the round brackets and put the name of the file. But I don't have yet the name, because here, like you see, I don't have an Excel file. How can I create an Excel file from zero? Very easy. I can just open my Excel and insert, data from text CSV, going inside my path, take the first one, characters was the second one, just import, very easy, load. Here I have a dataset already made, very easy. Just let me save in the same folder where I want to work, just more location, just browser, just let me put here, and let me call with the name characters. Perfect. Here I have perfect Excel. Let me just copy the name of the file, and we can import in a very easy way. So just Ctrl C, Ctrl V, take a little bit more time, and here very easy, I got the same dataset, of course, because I copied the same dataset. This is a way to read an Excel file. In the meantime that I try to explain you the different way to open an Excel file, I show a little bit of tips on this dataset. Say for example, if I want to access to all the columns of this dataset, I can do very quickly df columns, and now I can access to all the labels of the columns in my dataset. I can access to the index as well, like this one, for example, from 0 and stop in 166. And I can do, of course, the same thing I can do reading an CSV file. So for example, if we want to access to character name, very easy, like the same before. So I put 0, let me put a pick, perfect. Alt Enter to duplicate, to duplicate the row. Now, another things that I can do, but I don't show you, I will prepare a dedicated video for that, is to read an SQL file. To read an SQL file, I will explain you in a specific video on that, because it's quite different. Now let's jump to see how to read a JSON. Read a JSON file. How can I read a JSON file? JSON file is like before, df dot equal pd dot read JSON, and we put the name of the file in a JSON format. Of course, I don't have yet the JSON file in my directory, but I can create it. Say for example, convert convert CSV to JSON. I can jump directly here. I can copy my JSON file, my CSV file, double click on that, just Ctrl C and go into here, Ctrl V, just here I can just convert, it's already converted to JSON file. I can just copy using my notepad, open another one, Control S, putting in the same path where I have all the stuff, Control C here. I was already there, so I can name characters.json, and I have a JSON file right here. Very handy to sometimes to have a JSON file. I can just see with JSON viewer, format JSON, plugins, JSON viewer, show JSON viewer. I have all the object here, and in a very easy way I can return to my notebook, close this page, and I can just run again this command. No, sorry, it's without this one. Probably characters, name is Anes. Perfect. And yeah, the same like before. So just say, for example, if I want to manipulate more this data, what I can do is, let's say, for example, I want to just to do a recap of all that stuff. We can just, how can I read the index? Index is very easy, just df.index. How can I read the columns? I read the columns, just like that, df.columns. A very important part, you see that Jupyter Notebook show you only the last command that you run. So if I delete this one, I can see the index, but if I overwrite, I can see the only one, even if Jupyter execute this one. Another things that I want to show you is about how to create a data frame with Pandas. Is a very handy things. Let me transform into a markdown cell again, hem twice, and then I'm gonna do, let me just create a data that will be the basic array to create our dataset. So we built an array just with 3 elements, for example. You can just put, for example, Tom Riddle. The first name could be the name, and the second one could be the power, for example. The other one could be Albus the magician, and the other one could be whatever we want. I don't know, we can just say Merlin. Power 10. And then we can create the data frame with the constructor that is data frame that taking input the data, and we can specify the columns label. The first one, for example, is the name, and the second one could be the power. And then just let me print. So this one is to print the data frame. This one is about create the data frame, and this one is about the data inside the dataset. Very easy way we can just have our own dataset. Let me modify now so we can understand how to create a dataset, how to read a CSV, Excel, JSON file, how to read directly from Google Sheets, and now let me jump into modifying a file. So this one is about modifying a file. How can I do that? So let's, for example, let me create the same, another dataset that I want to modify. I want to show you how to modify. Let's, for example, create a rectangle _1, and just let me put, for example, the height and the width. Sorry, rectangle 2, just 1, 2, and rectangle 3, just 5, 2. We can specify that the first one is the shape, the second one is the height, and the third one is the width. Let's create the dataset. Okay, very easy. How can I modify this dataset? Of course, I can modify it whatever I want of this dataset. I can modify it even a dataset that comes from a CSV. It doesn't mind, because now we speak only about dataframe. So it doesn't mind if it's come from a CSV, an Excel, a Google Sheet. It doesn't mind. For example, I have this kind of dataset. I want to create another column that calculate, for example, the area. So just let me do like this area, or in a proper way we can just do a lock like this, and this one is about the f.lock height multiply width. And now if I read again my dataset, I can see another column that calculated the area. That's a way to modify in a very easy way my dataset. For example, another things that we can use is, so this one is about adding a column that is the combination of another column, but we can just, for example, drop a column. If I made, for example, a mistake, if I say that is a volume, for example, for sure is a mistake, because this is not a volume, but this is not the calculation to get a volume, but it's a calculation to get the area, and I want to drop it. Very easy way. What I can do is df.drop round squares and then volume. Sorry, maybe I have to specify the axis equals 1. Perfect. And now I can see my volume is deleted. But stay careful. Stay careful, because if I run again my dataset, I can see again the volume, because I have to define again, to instantiate again my data frame to remove once for all my column. And now if I run it again, I cannot see the volume. So that's perfect if you want to delete some step, some column. So that's one for, just let me write here, just for you, how to delete a column. If I want to renaming a column, what I have to do is, say for example, I made a mistake. I want to calculate the perimeter. So df.perimeter, and I made a mistake. I add a t at the end. It doesn't mind. We can fix later. So the perimeter is calculated in a very easy way. Just let me copy this one inside here and just plus. Perfect. This is a perimeter of a rectangle. I can see all my data set, but could I have a problem on that? So say for example that say for example that I want to rename this column, the syntax is very easy. Just df dot rename columns equal braces the old name and then the new name. In a very easy way, from this one I pass from this one. But stay careful, because if I run again I have the same problem. So what I have to do is just df equal renaming, and then that's it. Now I have once for all permanently deleted the T at the end of my columns. How can I change the index? Another things, just another tips. I give you some tips here. Meantime, I explain all the flow. If you want, for example, to access to a column, you can also doing lies perimeters, very easy way, or I can do last with the width. But stay careful, what's happen if I do, for example, the shape, the first column. Let's see, you can see 3, 5. Why? It's completely different, because shape is a particular keyword that is used to understand the dimension, the shape of the data frame. 3 rows, 5 columns. So stay careful to use this type of syntax. I never use it. I prefer the ILOC, that is the proper way to access to a dataset. Perfect. You cannot be wrong if you use loc on ILOC. Let's jump into another concept, is changing and reset index. So let's say, for example, how can I access the index? We already know, we already see. Very easy. But what's happening if I want to change my index? I want that this value is my index. Perfect. In a very easy way, what I can do is df equal df dot set index. Don't forget set index. And then we can just put the name of the column, shape. So right now, my new index is rectangle 1, rectangle 2, rectangle 3. What happens if I print my dataset? I can see a new index. Just about this, I have another tips for you, because you have to stay careful if the shape is a unique column, because it's important that the index is unique. And about this one, this is a particular things that I want to show you. Say for example, if I copy this dataset here, I put just here, and I duplicate. Let's just formatting better this one. Perfect. I want to duplicate this one. And here I can just put 0.0, 0.1, and here 0.03. If I want to change my index, I can do as well, just copying this. And the problem with Pandas is that it's not a problem if this shape is not unique. You have duplicate index, and personally, usually I don't like if the index has the duplicate inside. To prevent this type, to block this type of behavior, you can just specify the verification of integrity So here you can just put, let me create again this dataset. Here what I can just specify is verify integrity equal true. But right now, see, I cannot see because there is a duplication on the index. So my suggestion is to enable always this verification integrity, because it's very, very handy. It's very, very bad, I think, that the index has duplicated inside. Let me jump right now in another concept that is working with the date. Working with date. So let me create a dataset with the date, because we don't have yet a dataset with the date. How can I do that? So create a dataset. The data just let me copy this one. It's very handy to copy this one. So let me say, for example, I don't know, we need 4 events. The word second starts. For example, it starts, I think, for sure here it could be this one. I don't remember, probably we can just Google it very quickly. 1 September, very easy. So 01 09 193 1939, and then we can just using the same but the end. The ends I think should be very similar to this one, but 45, and then probably just let me check here. Okay, it's 2 September. So it's 2 September. Just let me, for example, another huge event landing on the moon. And this one is around 1969. Let me check the date. What is the date of that? Is okay, 20 July. So 2007/8. The year is correct, perfect. And then just adding another one, probably this one I'll be able to remember because it was a huge event. It's the 11/09/21 probably. Okay, it's fine. We have 4 events. It's perfect. We have 4 events. Should be this one the date. Let me check. I don't want to make a mistake here. But probably is, yeah, it's very famous event. It's very recent event. So we have 2 columns, event and date event. Date event. Perfect. So here what we can do is investigating on the type of the column. Right now it's very easy, we already know how to do that. It's just type df.loc and putting date event. Okay, what I'm missing, date event is not present. Why? Oh, sorry. Why is not present? Data lock. I don't run this query, sorry. Okay, perfect. I run again. Is a series. Of course, it's a series. But if I take, for example, the first one is a string. Is a string. And this is a problem because with the date, usually I want to do a lot of stuff. I want to do, for example, make the difference between the two age. I want to order by age. But if it's a string, I have a big problem. So what I can do is using a library, very famous library that's called datetime, and import the sub library that is called datetime as well. Using datetime, I can transform an object to a string. So datetime, let me see, for example, object is equal to datetime dot string to time. Let me specify, for example, the day today 02 0. This is April, so January, February 04. Sorry, I don't remember. 23. Perfect. If I run this command, I import this dataset. Perfect. So let me see what I'm missing. Datetime. Perfect. Sorry. Of course, I have to specify the format. To specify the format is %, the day, %, month, % here. % here. Just let me put this one. Great. And now I can see that this object is a datetime object. I can work with different type. For example, if the data is written with the score, for example, I can just modify this one and put just this. So if I want to use the dash, for example, so for example, if I want to modify the data using the dash, I can do that. And then if I want to use, for example, the date only with the last two chars, I can do just like this. And using a lowercase formula. Perfect. This is a way to obtain from a string a date. But how can I apply to all my series? Because I have a problem in all my series. There is a lot of way to do that, but my favorite is using this one, because with this one you are 100% sure that you can specify the format of the date and you can handle whatever date you want. It's very handy things. So to do that, just create date event, overriding the date event, but I'm using lambda. Function. It is very easy to use. So you have to do a series, then apply is like stream the lambda, doing it just like that, the event, and then datetime dot strp time, and then what I have to do is just copy this one. So here just putting he, and that's it. What I'm missing, just let me check. Probably I made a mistake. Date is not defined. Oh, sorry, this is df. For sure, this is df. I made another error. Does not match. Perfect. You are true, because I have to put it just like this. And not the dash, but the slash. Perfect. So if I want to read this one, I have right now the datetime. So what's happened if I run the same things that I run here? Perfect. Now I have a time stamp, a form of datetime. And right now I can do whatever I want. For example, if I want to calculate the distance from now, I can just create another column and call it distance from now. Distance from now, just distance from now, and I can do just df, and then what I can do is date event minus today. I can just run today again. Just let me put here, perfect, and I can print this one as well here, perfect. The best things is to invert this calculation to get non-negative value, perfect. And here I can get, for example, the date. There is the year. There is a lot of way to get here. We can do with a lot of stuff, but for now, just doing in the most easy way, the easiest way. So to get, we can just so this one is expressing days. If I want to get the days like the number, I have to do datetime dot days, and I got the distance like integer. Okay, easy way. If I want to here, if I want the here, I know that is not correct, that is not perfect, but an easy way could be this one. Let me just print, perfect. And now what I can do is, if I print the df, I can see that, for example, I want to sort from the most recent. I can do just sort values, and by what? I can specify it by what. I can sort by the distance in here. So the first one is towers, the twin towers fall, of course, then landing to the moon, then the World War second hands, etc, etc, etc. So that's a way to handle the data. I create a specific video on how to handle the data. We can see properly in another video. Now I explain you how to remove duplicates, missing value. Right now concentrate ourselves only on the duplicates. So let's say, for example, I can copy, just let me take again this dataset. It was very handy because it has already duplicate. Just adding another one, say for example this one, perfect. So there is a lot of way to remove duplicate. The first of all is df dot duplicated, and here you can find all the duplicate, but you have to stay careful when you think about the duplicate, because it's important to understand what we mean for duplicates. We can have, for example, duplicates because all the columns are duplicated. We can have a duplication because the values are approximately similar. We have to stay careful on that, and we have to study properly the strategy that we would like to apply to choose the duplicate value. Right now I can see only the first one has the all three columns duplicated, so for sure is a duplicated value. I can remove it, I can save it, it depends on a lot of stuff. But right now, if I want to remove, it's very easy to do because I have to filter. It's like a slicing operation because this is a boolean. So like we see before when we spoke about slicing here, we put the condition to slice here, and it was very easy. We have to copy the same stuff. So this is the condition on rows duplicate. Just let me print again this value. So I have to filter only the one that I want and all the stuff again. Sorry, here there is a problem because I have to do the opposite, of course, of this condition. I know that I'm going to show you right now a thing that is not so handy, but there is no way to do that. Is using a tilde. We have to use this type of accent to revert this solution. It doesn't work, for example, with the okay. So in the same way, if you want to remove the duplicate, we can just using the filter, just lock using the condition, and then we can just use the okay, if you want to work with removing duplicate, what we have to do is just filter this duplicate value, just moving this one here, take all the columns and see what's happened. Right now I have only the first one because I select only the true one. I have to revert this condition, and to revert this condition, I know that is not handy, but we have no choice. We have to use the tilde one. It's maybe called also tilde. We have to use this one, and now we have the opposite of this. Or we can just copy here, just as this condition, and select the only one that we want. This one is the exact symbol that we need to transform the false in true. I know that is not easy to find because the tilde is not easy to find, but that's the way to do that. Then what else we can have? Stay careful, like I say, stay careful, because you have to understand the strategy of removing. Say for example, you have 1,000,000 of row, and you have a lot of duplicate. You have to establish a strategy to remove this duplicate. Say for example here, for the rectangle tree, I know that I have some duplicate values, not in only the three rows, the three columns, but I have only about the shape one. Only in one column I have a duplicate. How can I access to the duplicate to only one column? Like I show you here, you can specify here a subset that is called shape. And here we can see we have 3 true. Now, how can I remove this one? How can I remove this one? Not always we have to remove drastically. We have to remove immediately the value. Because I see the shape could be for me an index. I don't know, it's a unique identifier, for example, and I have to choose between these 3. But not always removing the last 2 ones is the best choice. The best choice could be, for example, made an average, a median of this calculation. So let's say, for example, a group by that we see before, but now I explain a little better. We can do a group by shape. And after do a group by, it means that I want to merge this value inside. If I group by shape, I want to merge this value inside only one row. And I want to merge this one. This one is no more duplicated, but anyway, I can do that. I want to merge only one row. How can I do that? Group by shape, and then what I can do is a mean, for example. This is the average. It's the best option in this case, because I don't delete this value, but I take a mean, all the value. For example, we can use in a lot of stuff. It could be the different measure that I take of a table. And if I want to make a precise formula, I have to do the mean, I have to do the average. Or I can use otherwise the median. The median. It's very handy to use the median. Stay careful when you delete something. And we can do as well here, for example, with this group by is very handy because we remove directly the duplicate. Our index become the value that right now we do a group by. So the shape, we do a group by for shape, and our index is the shape. It's very handy because we are sure that is a unique value, because the group by must be, if we do a group by, must be a unique value. And here we can just do whatever you want. For example, we can do a plot again, like we see before. Kind bar. It's very good to use. We can just put a title, for example, title probably is just like this. We can find a lot of documentation on that. Rectangle plot, say for example, I go to the title. So just jump right now into before going into the next topic, I just want to show you another important tips, that is the describe function. The describe function is very handy because you can obtain in a very easy way a lot of stuff about the numerical column. So we have 6 elements. The mean is that one, the standard deviation is that one, we have a mean, we have a max, we have the percentile, this is the first one, the second one, the third one, the fourth one. So it could be a good function if you want study numerical columns. Anyway, just move into removing null values. So now let me explain how to removing the null values. To remove the null values, just let me copy the previous file. Probably is read CSV. Perfect. Just let me copy this one. Okay, here we go. Just let me read this file. We can just print this file. Perfect. And we want to remove some null value. First of all, there is a very powerful command that is very simple. df drop na hen hey, and this drop the null value. But see, even if we speak with null value, one important thing is what is the strategy that we are going to use to remove the null values. Someone can think that the null values must be removed at all, must be removed always. But it's not always the best choice. And the reason is very simple. Now I'm going to show you just another step, and I will explain very carefully this part. Let me just explain you how can I drop the null. This is a way how I drop all. I can drop in this way. I can drop the row the row that presenting at least one null value. But here I can specify that I can drop the rows presenting at least one null value in a specific column. How can I do that? Specifying again subset is a subset, very easy. Let's say for example the gender, and now I get all the 125 element that has at least one value, that has one value in gender. But the reason why it's not always a good strategy drop the value that has the null value is because suppose that we have a dataset with 1 million rows, and I want to create this dataset with this dataset. I want to create a model that taking inputs, for example 3, 4, 5, 6, 10 columns, and return the value of a prediction. Say for example we have a dataset like this. So we have a dataset like this. We have a dataset like this. Let me, for example, we have age. We have if is a smoker. So we have a dataset like this. Is a dataset about the cancer at lungs. And we have a dataset like this, the age of the person, if that person is a smoker. We have his practice sports. We have another column about, I don't know, nationality. And another column about the blood group, So let's say, for example, I have all the column and I want to predict, for example, this is the predictive if as a cancer on lung. So for example here, if I have 1 million rows of each dataset, of this dataset, in this dataset 1 million rows, and I want to predict if this man has a cancer. And for example, it's very difficult sometimes to get the blood group of 1 million person, but probably it's very easy to understand if he's a smoker or not, if practice a sport or not, and the nationality as well. So if I have this 1 million dataset, and for example 30,000 has not have not blood group, should I remove these 30,000 of rows? No, because in this word the dataset is very finding a value of data in 2023 that has so many rows and so with a lot of quality of data. Find a dataset with high quality is very difficult. So why I can drop 30,000 of blood or 30,000 of rows? Only because they have the blood group not fill. What I can do is, for example, not drop all these 30,000 row, but substitute these 30,000 with, for example, the median of all the dataset, with the average of the dataset. This could be a solution, because I want to have the age, I want to have if it's a smoker, I have all these, suppose I have all these columns filled with a good value, and now I have to drop 30,000 rows only because the bloat graph is not present. So stay careful, because not always remove a null value is a good option. Then we can jump with another concept, that is the join operation. Join operation is very famous, and you can find in, for example, in SQL as well. Let me Google it, for example, join operation. Here, let me take a picture. Let's say, for example, this one. Let me copy this one here. Okay, we can have a join, full join, left join, right join in SQL and in Pandas as well. I'm gonna show you very quickly. And let's say, for example, we can read again this dataset. And another dataset very useful could be the dialog, because if I see into the dialog dataset, let's jump here. I have, for example, the dialog ID, the chapter ID, the place ID, and the chapter ID and the dialog. So if I want to know, for example, who used this sentence, who say I should have known that you would be here, Professor McGonagall, I can know because I have the character ID. So I'm looking for the 4-1. The 4-1 is Albus Dumbledore. Perfect. Very easy. How can I do that with Pandas? Just say, for example, I want to read this file. Just putting dialog CSV. And the operation that I have to do is the join operation. So, how can I do the join? How can I do the join? So first of all, we choose a specific row. Let's say, for example, we want to choose, let's jump into the dialog. We want to choose, I don't know, just Dad, look, Harry has got a letter. I use in the past this type of comment, this type of dialog. If I want to search who say this sentence, very easy. Condition on rows is dialog that lock. Like I showed you before. Put dialog here. A string that contains this row. You have to escape this peak. The dialog is not defined. Sorry, because I want to use this one, and this one. It's fine that is character. Perfect. Just let me put this condition, and then using this one like filter. So we just put in this condition here, and then all the columns. Perfect. Is the chapter 31, but who is the chapter 31? The chapter 31 is, let me show you, is Dudley Dursley. So Dudley Dursley is the chapter 31. Let me just take a picture of him. Perfect, is him. Just let me copy here. So we can just put here and say character 31 is, copy the name here and put in here. Perfect. This one is the character 31. Oh, these images is huge. I don't know if I can resize. We can check. How to resize image in Jupyter Notebook. I don't remember how if it's possible. Okay, so we just putting this one, just putting here. And just perfect. We can just do no, it's not probably just 100. Maybe it's too small. Just doing 400. Perfect. I don't remember the sync. That's very easy. We can just copy this one. Okay, great. How can I know directly that? It's very easy. We have to do just a join. Very easy to do a join. Very, very, very easy. In SQL and in Pandas as well. We create a dataset that is merge. That is the df with the character and merge the df underscore dialog. We have to put the left on key, that in this case is the character ID. So the left is about the df. The df, if I print the df here, is the character ID. Perfect, is the same. And we have to put the right on, that is the right on is the df dialog. So left, right, and the left one is the character ID. Just let me put this one here, and there we go. We have the dataset perfectly merged. Let me use now the condition on dataset, and if I use the condition on this dataset, so just let me copy this condition. This condition is about the comment df underscore merge. Perfect. Then we do df underscore merge dot lock double point, and then condition on rows. I can see one shot that this sentence that look Harry got a letters is Dudley Dursley. Very quickly, very easy. We can do a merge whatever we want. It's very, very handy to do. We can merge multiple tables, just merging twice, two at the same times, and then merging with the third one, with the fourth one, and so on and so forth. The last topics is how to export a dataset. And this is very, 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 very useful things. So let's, for example, we want to export this dataset here, and we want to create a CSV file. How can we do that? Very easy. df underscore merge that to CSV, and then specify the name. df underscore merge, or we can just give the good name. For example, this case is characters underscore dialog dot CSV. And here we have our dataset, our CSV, ready to be read. And we have all the sentence here, and it's very easy and very handy to use. Just say, for example, right now we want to create an Excel file. We can do as well an Excel file. We have just modified the extension XLSX, and we can do as well with JSON file. JSON. JSON file. Perfect. Here we go. Here we have the JSON and the character dialog file. Very easy. Here we can have all the stuff that we need. So it's very easy to work with that. Just another things, we can just use the delimiter, no sorry, it's the SEP here. We can specify which type of CSV we want. For example, let's say we want the tab 1. Okay, very easy. We created the tab 1, and here if I refresh, I can see a new CSV reload with the tab 1. We can just, for example, select, for example, this one. If I go inside, refresh again, double click on that, we have this type of symbol. To read a file, stay careful because there is could be a small problem. If I read the CSV, I can specify the delimiter. It's a little different, but it's pretty similar. Is just like this. Delimiter. CSV, of course. So delimiter when you read a file, SEP when you export a file. And there we go. This full course right now is conclusion. We are on the conclusion steps, and what we can say. Data Pandas here. Data Pandas here. If you want access to my website, in my website you will find this Jupyter notebook. I will add very quickly a new box where you can find this Jupyter notebook. You can download this Jupyter notebook and you can use this Jupyter notebook. Don't forget to follow me in Instagram, TikTok, YouTube. And just another thing, just the last one. If you have any question, please comment the video below, and thanks for watching.